Hello everyone. So we are back again here. We are going to see another different type of implementation of queue. And now we are going to implement queue using linked list. All right. So let's start. So we saw in our earlier video, we saw that how to implement queue using array. All right. But when analyzing all the operation, NQ and DQ operation, we saw that the worst case runtime in array-based implementation is order of n. Okay. Now we are going to find out whether we can find a linked list based implementation where the operations means the NQDQ operations, we can make the NQDQ operation efficient, much more efficient. Like our goal is to make both of the operation in order of one runtime. All right. So let's see, we are going to implement a queue using singly linked list. Okay. So in singly linked list, you know that this is our head pointer and this is our head node. Okay. So this is our head node and these are the value of our queue. All right. All right. So now when we'll implement a queue using singly linked list, we have to figure out which is actually our front node, means which is the front item in the queue and which is the rear item. Rear means the back item in the queue. Okay. So if we insert a new node in the front of the list, okay, so we have to figure out how do we enqueue a new item, all right, and enqueue a item, and how do we dequeue item. So if we consider enqueuing from the front of the list, okay, so let's say the enqueue is going to insert at the front of the linked list, all right, means we are going to enqueue 50. Okay, so what we can do, we can enqueue 50 at the front of the list here. Okay, so then this will be our updated list, updated link. Okay, all right, so what does that mean? Now we are inserting a item in the queue. We insert an item at the end of the queue, right? So here we are enqueuing the item at the front of the list, means this is the last item in the queue. Okay, so means this is actually our rear item in the queue, and this is the front item in the queue. All right, so in this scenario, this is our scenario where we are inserting a new node at the front of the list. Okay, means enqueue takes order of one runtime, because you have to just look at the front head pointer, which is the head node. All right, and you have to need few operation to insert a item at the end of the head node. All right. All right. Now what will be the runtime for DQ? So you can see that in this implementation, the front item in the queue is actually the last node in this list. All right. So if when we are going to DQ an item, we have to traverse the whole list. Okay. And we have to delete the last node from the list. All right. So DQ means we are going to delete the last node from the list. So that will take order of n runtime. Okay, so in this implementation, enqueue, so enqueue takes order of n, enqueue takes order of 1. Okay, so which we preferred and which is very efficient, but DQ takes order of n. Okay, and that's both best case and worst case, because the front item will be always at the end of the list. Okay, now let's think about the reverse strategy, means each time we are going to insert an item, each time we are going to enqueue item, we are going to enqueue from the end of the linked list. Okay, so let's just have a different color. So in this strategy, we are going to insert item at the end of the list. For example, insert 50 means we are going to insert items here 50. Okay, and 50 will point to null. So that's our enqueue operation. Okay, enqueue operation means we are inserting at the end of the list. Okay, now in this strategy, enqueue will take order of n runtime, because you have to traverse the whole list and insert at the end of the list. But DQ will be easier because DQ means actually we are going to delete the front item from the list, the item that is pointed by the head node. Okay, so we can just follow the head node. Next pointer, we can delete the front node, and we can just take care of the next pointer of the head node. Okay, so here I'm assuming 40 is actually our front node. Okay, so we're going to just adjust the next pointer of the head node, and that's how we can delete the front item from the list, and that will be our DQ. So means we don't have to traverse the whole list, we have to just delete the first item, okay, from the list. So that is just few operation, and in big O notation, that's the order of one runtime. Okay, so we can follow any other strategy. Okay, so but in each strategy means order of nq takes 1, dq takes order of n, and in this strategy nq takes order of n, dq takes order of 1. Okay, means either one operation is going to take order of n runtime. All right, so what if we want to implement both of the operation in order of 1? Can we do that? Okay, all right, so let's see we can implement the queue using doubly linked list. All right, so by implementation of your homework, I mean your recent homework, you will be actually comfortable by implementation of the doubly linked list. But we already know the concept of doubly linked list and the difference between doubly linked list and singly linked list. Okay, so doubly linked list means each of the node will have two pointer. Okay, head pointer will point to the first node of the list and tail pointer will point to the last node of the list. All right, so if we implement a queue using doubly linked list, all right, in that case we'll have a pointer. Okay, using the head pointer, we will have the pointer which is pointing to the first node of the queue. Okay, let's say this is our first node of the queue. All right, we'll have a pointer that is pointing to the tail node. This is pointing to the head node. Okay, tail node will point to the last node of the list. So we have a pointer for the front node. Okay, so we can access the front node and we can also access the rear node, both in order of one runtime. Okay, so if we consider the first node in the list as a front node, okay, uh, all right, then DQ will become order of one runtime. Okay, because DQ means deleting the first item in the list. And if we consider the last item, okay, so in the scenario, the last item means the last item will be pointed by the tail pointer, means whenever we insert a node, we are going to actually insert the last item. We can insert the last item by using the tail node. Okay, by following the tail node. So insertion or NQ will be also order of one runtime. Okay, so this is the class definition of our doubly linked list. All right, so in doubly linked list, we have the access to the front node and the last node, rear node in the list, both in order of one runtime. So both NQ and DQ, we can make it in order of one runtime. Okay, all right. Now let's just look at all the scenario of the queue. So we're going to look at the NQ operation, and we talked about what does a completely empty doubly linked list looks like. Okay, so this is a completely empty doubly linked list. So in a empty doubly linked list, we will just have a head node, we'll have a tail node. Head node is pointed by the head pointer and tail node is pointed by the tail pointer. So head node, next pointer of the head node will point to a null pointer, and the previous pointer of the tail node will point to a null pointer. So it's just a completely two different node, all right, pointed by head pointer and tail pointer. Now this is our first scenario. Let's say we don't have any item in the queue and we're inserting the first item in the queue. Okay, so then how it is going to look like? So we have to insert a new node, all right. So we have to first insert a new node, all right. So this is our first node and this is actually our last node. So as this is our last node, all right, so its next is going to point to null pointer, all right. As this is our first node, it will be pointed by the next pointer of the head node, all right. As this is the last node, next is pointing to null, and as this is the first node, the previous will also point to null, okay. And as this is the last node, it will be pointed by the previous of the tail node, okay. All right, so now you can see here it's the scenario after the enqueue. That means we just inserted the first item in our queue, okay. So head pointer is going to, the next of head pointer will point to the new node. As this is the last node, okay, it's actually the only one item, so this is also the last node. The next of the new node will point to null. So also as this is the last node, the previous of tail will point to this node, okay, and the previous of new node will point to null. So all of this mark is coming actually from here, from this implementation, okay. So this is the line of our one, means we're actually creating the new node, okay. So we can see here 1 2 means here the next of the head pointer will point to the our new node, okay. And here 3 means the next of new node will point to null, okay. We'll that's how we are going to adjust that. And this line is saying that the previous pointer of the tail node will point to the given node, okay. You can see here by 6 the previous of the tail node will point to the new node, okay. All right, so here here we are going to see another scenario, means there are at least some node in the queue, okay. There are at least some node in the queue. So before we are going to insert the new node, the previous node pointer from the tail node is going to pointing to the last node, all right. So so here each of the NQ we are going to insert at the end of the list, okay. So it doesn't matter how you are actually inserting. You can insert at the from the front of the list, or you can insert at the end of the list. That's totally up to you, okay. But whenever we are going to NQ and DQ, we have to follow the order first in first out, okay. So as we have both the head node and tail node, all right, we can make both of the operation in order of one. So in this scenario, let's say we are going to insert from the end of the list, okay. So as we are inserting from the end of the list, we are going to follow the tail pointer to insert at the end of the list, okay. So you can see that here we have few items, node 1 and node 1, node 2, and this is the last node in our current queue, okay. This is the last node in our current queue, and when we're going to insert the new item, means we're going to enqueue some items in this list, we are going to insert from the end of the list, okay. So that will be the scenario here. We are going to create the new node. We're going to adjust the next node of the last node. Okay. So now the last node is being pointed by the tail node, but now the new node will be pointed by the tail node. Okay. Here this node is pointing the null. Okay. But here this last node will now point to the new node using the next pointer. Okay, new node previous is going to point to the this last node. Okay, and here this is our last node. Okay, so it is going to point to the null pointer. Okay, and all of this mark you can see actually from this implementation. Okay, here from this implementation. All right, so you can see this is our order of one. So here we are inserting from the end of the W item linked list, means the first item from the W item linked list is always the front item. So this is our front node. Okay, and in this scenario this is our rear item. Okay, rear item or rear node or the last item from the queue. So DQ means we are going to always DQ the first node. Okay, so in this DQ we are going to also see two scenario. In the first scenario there is only one item, means after we DQ the queue will be empty. Okay, means queue has only one item 10. All right, so after we DQ the queue will be empty. So this is the scenario. So when we are going to DQ the first node, we have to make sure the queue the W linked list becomes empty. So the W linked list is going to look like the empty list, and this is actually our empty list. Okay, means, so you can see that head, next of head will point to null. Okay, and the previous of tail will point to null. Okay, so you can see that this is our empty list looks like. The second scenario is that we have some of the some of the items in the queue. Even though we delete the front node from the queue, there will be still some node. Okay, there will be still some value in the queue. All right, so this is the scenario here, and after we DQ that is going to look like this. So we're going to pick the first node. All right, so and we can do that by following the head node, and that is going to take us order of one operation. But after we delete this first node, we have to make sure we have to take care of both the next pointer and both the previous pointer of couple of nodes. For example, now head is going to point to this node after we DQ this item like this. Now next is pointing to the first node, but at the end of this deletion, next this node will be the last node from our queue. Okay, so that should point to the null pointer. All right, and everything else is going to look like same. All right, so still this is actually our order of one operation, because we can do that by following the head node. All right, and insertion we can do the following the tail node. All right, so pick is order of one operation, because pick means in this implementation the first item in the W linked list is our front node. Okay, so we can just follow that the next pointer of our head node, and we can see the first item, and that's also order of one operation. So in this implementation we can say that we can see that all of the operation we can actually implement using order of one. Okay, so in the W item in the W linked list based implementation has the runtime with order of one. All right, all right, so that's all about our implementation of queue data structure, and in the next class we will talk about a new data structure. All right, you guys have a nice weekend.